Hello everyone, my name is Nijat Mammadov and I hope you are having a great day. Well, I'm having a great day, so today I'll explain how to find the properties of a function by scratching it, by making a scratch of it. So I'll just start with a function, then we can start working on and find its properties. I'm going to use the green one. So we can go this one. That's a minus 3x. And let's add a 3. Okay. So to find the properties of the function, what we'll need, we can have a question like find when the function is increasing or decreasing, or find when the function is concave up or concave down, or find the inflection point, or find the critical point. So how do we actually find these? Well, to find these, first all it comes down to derivatives. So we'll start with critical point because it's the first derivative. So I'll actually use green one. So to find the critical point, we'll find the first derivative of the function. Then we can find where the function is increasing or decreasing, which I'll show you later. First we'll find the critical points. The derivative of this will be 3x minus 6x, and that's 0. So this is the first derivative. And to find the critical points, we have to equal this to 0. And then our critical points are gonna be, well, I'm just gonna put it like this, minus 2 equals 0. So our critical points will be 0 and 2. So how to actually find when the function is increasing or decreasing is now we're gonna take those two and we're gonna, actually I'm gonna use a different color. Let's use the blue one. It's not opening. Okay. We're gonna draw a line like this. Then we're gonna insert our critical points, which is 2 and 0. And for the visual, which looks cool for some reason, we'll just start testing numbers on the first derivative. So for example, since the 2 won't be included, so we can take a testing number as 3 and insert it here to see if it's going to be positive or negative. So if you put 3 here and it's positive, that means the function is increasing after 2. But if it's negative, that means the function is decreasing after 2. So let's just put the 3 here and let's see what it gives. 3 minus 6 times 3. And it's going to give 27 minus. Again, it's a positive number. So that means the function is increasing after 0.2. Now we'll find this interval to see if it's increasing or decreasing. I mean, we can choose 1, it's easy because it's between them. So if we put 1, it's going to be 3 minus 6, it's negative. Minus 3 is a negative number. So it's going to be a negative interval, and that means the function is decreasing. And before 0 we can put, get negative 1, it's an easy one as well. And this is going to be, wait, let me get the eraser. Okay. So for minus 1, you're going to get 3 plus 6 because the sign changes, and it's going to be minus a positive number. So that means our function is increasing in those intervals. Wait, I'll just type it so you can see. From negative infinity to 0, and we're not. Okay, you understand it. I forgot to say it, but yeah, the positive infinity. This is when the function increases, and when it decreases, it's going to be between 0 and 2. Well, now we're gonna go and find when it's concave up and concave down. So I'll start scratching the graph now. I mean, not scratching the graph, I mean just find the inflection points. That's what we need. Okay, so I'm just gonna change the red marker because so it's different. It's like Azerbaijan flag colors. I'm just gonna make a border here. So we found the critical points and when the function is increasing and decreasing. So now we find the inflection points and when the function is concave up or concave down. So this function, some functions might not have an inflection point. So then those functions are going to be either only concave up or concave down, but the function I'm using here has an inflection point, so it's going to have a concave up and a concave down. So to find it actually, the concave up or concave down, we need to find the inflection point, which is the second derivative of the function. And to find it, we just have to find a derivative of the first derivative. We just have to find the derivative of the first derivative, which we found here. So the derivative of this, basically, derivative of this, and it's gonna be 6x minus 6, and we have to equal this to 0, just like we're in a critical point. And this is gonna give us x is equals to 1. So just like in critical point, we'll just draw a line like this to find when it's concave up or concave down. And we'll just put our inflection points, but we only have one, so we'll just put 1. So we'll just do the cool thing again. Now we just put the after 1 the values here and the before 1 values here to see if it's positive or negative. And so after 1 it's gonna be let's just put 2 plus like that one. It's gonna be
12 minus 6 is 6.
which is positive if you didn't know. So this is gonna be a plus. And before 1 we can 0 is the easiest one. Yeah. So 6, no, it's gonna be 0 minus 6, which is minus 6. It's a minus, it's the minus. So, well, we found when it's concave up or concave down. So after 1 it's concave up, before 1 it's concave down until negative infinity, and this is also for positive infinity as well. Now, now we found those, we can actually sketch the graph now. I'll change to the black marker because I use all of them. Oh, so it's actually good. Okay, so we'll just mark the critical points and inflection points for easier sketching. So our inflection point is at 1. That's 1, 2, 3, minus 1, minus 2, minus 2, 1. Now we have to find the y values of our inflection point, and to find that, we can just insert our inflection point to the original function, and that's going to give us 1, 2, plus 3. It's going to give, I say 1. So we're going to mark this here, and for our critical points, we're going to do the same. When I put our 0, it's going to give us 3. So this is one of the critical. Oh, I shouldn't do that. It's one of the points. And when we put 2, I have to actually write that one. 2, 3, 3, 2, 2, plus 3. And that's going to give us 8 minus 12 plus 3, which gives us minus 1. Yep, minus 1. So for the 2, it's going to be minus 1. So around here. So now we can kind of see where the function is going. So we'll just draw a line here. And since we know it's concave up after 1, so this has to like go like a smiley face. So after 1 it has to go like a smiley face, so something like this. And we know before 1 it has to go like a sad face, a frowning face. So it's gonna be going down like this. And from here we can see the local maximum, local minimum and local maximum points as well, if you have a question that's asking you those values. And that should be it. Well, I did a lot of improvising, so thank you for watching and have a nice day.